Hello everyone and welcome to the first of a series of math tutorials. I'm your tutor, Vaughn G. This series has been conceptualized and commissioned by the Counselor for the Bridgeport Division in the Municipality of Portmore, Counselor Kennard Grant, building a better Bridgeport. Today, we'll be diving into the wonderful world of algebra. Now, these may be videos, but you should definitely arm yourselves with your notebooks, pens, pencils, and maybe even calculators as may be necessary. Let's start off with a tip for our sessions. Treat these sessions like actual classes. Writing helps with memory, so please do write down information you find interesting and important. Being actively engaged in these sessions help with learning. Now, let's get into the meat of the matter. Our focus for this session is replacing variables with numbers, but we're gonna begin with some foundational information, and we'll do that by answering these essential questions, or EQs for short. Number one, what is a variable? Then we're gonna answer the question, when do we use variables? And then, to close off the foundation, what is the main difference between an equation and an expression? Now, what exactly is a variable? Usually when we think about math, we think about numbers. And we're right. Numbers are a huge part of the subject mathematics. Now let's be real. By the time we hit high school, many of us get scared of math because the numbers start disappearing and letters start to pop up. Letters like X, Y, P, Q, R, and you get the point. But these are all examples of variables. Now here's some shocking news for you. If you think back far enough, you'll realize that you've been working with stuff like this since maybe even kindergarten. Yep. And back then, math was a breeze for us. So we actually have no need to be scared of variables. As Bruno Mars would say, don't believe me? Just watch. Remember doing something like this? 2 plus box equals 5. Yeah, you probably already figured out the number that should go into the box to make the statement true. That's because it is easy to recognize that the box is merely holding the place of a missing number. And guess what? That's basically what a variable is. But as we get older, we begin to use letters and other symbols instead of the boxes we used in primary school or kindergarten. So let's try to answer our first EQ. What is a variable? A variable is a letter or symbol used to represent an unknown value or number. So what are some cases in which we may need to use variables? Well, in the real world, we get problems we need to solve from time to time. Simple problems like figuring out whether or not it's worth buying the glass bottled ketchup instead of the ketchup that comes in the bag like sachet. I actually do that when I go shopping. I look at how much ketchup I'll get in the bottled one versus the sachet. Then I compare that with their prices. And then I try to figure out which one gives me more ketchup for the cheaper price. In this scenario, I do not know the cost of a single liter of ketchup in either container, but I can use a variable to represent that number and then calculate it afterwards. We'll talk about how we can do that in specifics in another video. The point here is that to solve my shopping problem, I may use a variable to represent a number I do not know. We also use variables in general formulae. For example, A basic formula many persons know is speed equals distance divided by time, or S equals D divided by T. Each of those letters are variables, and they each represent a number. In this case, the numbers can change over and over, but the statement will always be true for those numbers. Take for example, if speed, or S, was 50 kilometers per hour, when distance, or D, is 100 kilometers, then time, or T, would be 2 hours. But what if it was tracking Usain Bolt's speed in his record-breaking race? Then D would be 100 meters, T would be 9.58 seconds, and that would make his speed 10.44 meters per second. That's pretty fast. But in other examples, two different variables can even have the same value. For example, a car could be driving at a speed of 1 kilometer per minute, and the distance being traveled is 50 kilometers. That would make the time taken to complete the journey 50 minutes. In this case, D is 50 and T is also 50. So variables could represent different numbers in different cases, and sometimes two different variables can represent the same number because they are being used in a general formula. That's because their values may vary. Now you can probably see why they are called variables, because literally the value of each symbol may vary depending on the conditions. So, when do we use variables? 1. If we're solving a problem, we use them when a value is unknown. Or 2, we also use them in general formulae where their values can change from time to time. That being said, there are two very important facts about variables that we should point out. These facts, I believe, will help us to appreciate the value of variables in math and make algebra a little easier to understand. Firstly, variables represent numbers, which means we treat them the same way we treat numbers. We'll see that by the end of this video, and I'll further prove it when we begin to simplify algebraic expressions. And secondly, variables have value, but that value may be changeable or unknown at a given point in time. EQ number 3. What is the main difference between an expression and an equation? We could think of expressions and equations the same way we think about phrases and sentences in English. Phrases are incomplete sentences. We think of them as incomplete because they don't express a complete thought. For example, the car. That doesn't give a complete thought, and so we wouldn't know how to really process that. But a sentence expresses a complete thought. Let's illustrate that by simply adding to our phrase, the car. A sentence would be something like, the car is red. Now, we can begin to think about how the car looks, because I've given a complete statement describing the car. Note, all I've really done is to add a verb and then another phrase to make it a complete idea. So, how can we think of expressions and equations like phrases and sentences? Think of an expression as a phrase. For example, 2x or x plus y. Then, think of an equation as a sentence. Let's turn our expressions into equations. First, 2x equals 8. Or x plus y equals 17. In the example of an equation, I added an equal sign and information after the equal sign so that there are expressions or terms on both sides of that equal sign. The equation gives me a full idea of what the value of my expression might be, like a sentence does. But with the expression, there was no equal sign, and thus I didn't have a sense of what its value might be. Like a phrase leaves me without an understanding of what is being said. If we do a simple thing as just look at an expression and compare it with an equation, what is the one thing you might say is the difference between the expression and the equation? If you guessed the equal sign, then you're thinking exactly what I'm thinking. Expressions do not have equal signs, but equations do, and they have information on both sides of that equal sign. We can say then that the difference between an expression and an equation is the equal sign. Finally, let's try replacing variables with numbers. Here's an example. If x is equal to 2 and y is equal to 3, what is the value of x plus y? You probably figured out that the answer is 5. So let's talk about how we got that answer. We simply thought to ourselves, since x is 2 and y is 3, x plus y is the same as 2 plus 3, which is equal to 5. If we analyze what we just did, we could come up with the following 2 steps to be taken when substituting variables for numbers. First, we replaced the variables with their respective numbers. Remember, we use variables to represent numbers we do not know. But in the problem given, we know what the values of those variables are. They are 2 in the case of x and 3 in the case of y. So, since we know the values, there's no point in writing the letters we are so afraid of. It's just like writing the missing number into the box in kindergarten. Step 2. We performed calculations. After we would have replaced the variables with the numbers, all that's left to do is to perform the calculations we see before us. In this case, all we needed to do was to add 3 to 2, and then we got 5. It's that simple. Let's try another example. What is the value of 2x minus y if x is 3 and y is 5? Let's take it step by step. Step 1. Replace the variables with their values. I'm going to begin by writing the expression as given. The expression is 2x minus y. Next, let's replace the variables. 2 is not a variable, so I rewrite it. Next is x. X is a variable, but I already know what x is. X is 3. So instead of writing x, I'm gonna write 3. Note carefully though that the expression 2x means 2 multiplied by x, or 2 times x, which is why I can write 2 times 3. Next in the expression is the subtraction sign. It's not a variable, so I rewrite it. After that comes y. Y is a variable, but because I know its value, which is 5, I do not need to write y. I simply write 5. Now there are no more terms in my expression, so I'm done with step 1. Step 2. Step 2 is to now perform the calculations. Notice how at each step I move to a new line. I begin by calculating 2 times 3, which is 6. So instead of rewriting 2 times 3, I simply need to write 6 because that is its value. Then I rewrite the subtraction sign and the 5 because I did nothing so far with them. I now have the expression 6 minus 5, which I know is equal to 1. Therefore, in my next line, I simply write its value, 1. Now that there is nothing left to calculate, I'm done. It's that simple. And that concludes our lesson for today. The beauty about this being a video is that you can play it, pause it, and revisit it as many times as you like in case you missed something or you just want to make sure you got it right. But I never leave students without homework because we become proficient at math when we practice, practice, practice. So, accompanying this video is a worksheet with over 50 questions you can use to practice throughout this week. Don't be afraid to try them all. You get better by practicing. And don't try to do them all at once. Break them up into little chunks to build your confidence as the questions increase in difficulty. Thanks for watching. See you next time.